Hey folks, Prof. K here. Let's talk a little bit about problem solving. How do we solve problems? It might go sort of like this. I have a problem, so I guess I'll try and figure it out. And then if I figure it out, then I can make a plan to solve it, and then I can try the plan, and then we'll see how it works. That's a simple, basic, general approach, abstract, not a ton of detail to it. This approach was formalized by George Polya back around 1945, and it's still often used as a basis for teaching folks, especially things like word problems. You'll see it in a math book or something like that. Now, if we formalized it and turned it into a little box model, it would look like this. Here's a problem-solving basic model, and first we try to understand the problem. Then we make a plan to solve it, then we try the plan, and then we see how we did. Still not earth-shattering, right? I agree, but let's add some details, because it's when we look at what happens when we go through a problem-solving plan like this that we get to see where the problems occur in trying to solve problems. So here's what it would look like if I added a few details. Okay, so here's the first 4 steps, but then when you check the results, well, they might be good or they might be bad. If your plan solved the problem, then you're done. But what if the plan doesn't solve the problem? Now you got to go back. So when we do that, look, there's our buddy, the feedback loop. Okay, so you go through a full problem-solving plan, you check the results, the plan didn't solve the problem, you go back, and now you're into the feedback loop. Okay, the self-correction mechanism that we always look at in class to make things better and figure out some more. Now, if we do that, that feedback loop can go back to any one of the previous steps. In other words, if you check your results and the plan doesn't solve the problem, you go back. Well, where do you go back? Should I go back to step 3? Should I go back to step 2? Should I go back to step 1? So let's take a look at that. What are some problems with problem solving? Why don't we do as well as we'd like to? Another thing we'd want to add to our model is the problem of problem recognition. It's not always the case that everyone agrees that there is a problem, that we recognize it, and we think it's enough of a problem that we have to address it. So sometimes there might be a hidden step 0, recognizing that there's a problem. So I'm dropping that in at the top. Okay, so recognizing that there's a problem isn't as hard as solving it. So I like to call that a negative consensus. Identifying that there is a problem is much easier than understanding and solving it. It's much easier to get people to agree that there's a problem than it is to get them to agree on what is its exact nature and what should we do to solve it. It's like that joke in a recent TV commercial. I'm not a problem solver, I'm a problem identifier. There's a problem. So that negative consensus, agreeing that there is a problem of some sort, it should get us from step 0 to step 1, where the harder work awaits, where we're trying to understand the problem. But it can be hard to choose to step across this bridge right in here to understanding the problem, because trying to understand the problem, you're going to have to work hard and patiently to understand. So there's usually something that's much more tempting. When we recognize there's a problem, instead of crossing this bridge to understand the problem, we move too fast. The harder a problem is, the more work that's going to need to be done in step 1. So sometimes we'll just believe we already understand the problem, or we already understand it well enough. So we skip right to step 2. But what if we didn't understand it well enough? Oops, the important part has disappeared. We can't get into the feedback loop of understanding, so we start with the plan because we think we already understand it. We make the plan, we try it, we check the results, it fails, and we go back. We don't see this step, so we don't go back there, and now we're making and trying the plan over again. We're in this feedback loop where if the problem is a lack of understanding, we can't get to solving. Okay, so ideally, you cross the bridge into step 1. You don't move too fast. If you dig into step 1, what's that like? Like I said, it's easy to agree that there's a problem compared to how much harder it is to agree on the problem's exact nature and how to solve it. Very often in a difficult problem that people are trying to solve together, you'll hear people say, that's not the problem is this other thing. That's usually a cue that there isn't a sufficient consensus. And usually different people will have their fingers on different parts of a problem. So maybe there's a perception gap or an insight gap. And you can think of it as those assembled problem solvers are like the folks in the story of the blind men and the elephant. Here's our little cartoon here. In other words, there are people who have their fingers on different parts of the problem, represented by the elephant, And based on what each person is seeing, they have a different view of what it is. Okay, so the problem here that you can see in the cartoon is no one sees the whole elephant. Okay, so if we recognize the problem, we understand the problem, we've got to think a little bit more about the main details of understanding the problem. Without getting too complicated, two things that we want to do is we want to collect information and we want to analyze that full collection of information. So what I'm saying is when we're trying to understand a problem, there's a first part of that stage where we're collecting as much information to identify as much truth as possible. Then we analyze the full collection. We behave like an active editor. We sort, we filter, we make connections. So maybe we understand the problem. Do we think we understand it yet? If we don't, then we've got to go back and collect more information and make some more connections until we think we understand it. But once we think the answer is yes, we can go to step 2 and we can make a plan. So if we add the details of understanding, the model looks like this. It starts with recognizing that there's a problem. Then you try to understand the problem. How do you do that? By collecting information and by analyzing it. And then you make a plan. Once the plan is made, you can try it. And then after you try the plan, you check the results. Hopefully it works the first time, but if it doesn't, then you go back and you try other things. Okay? So if we understand the problem by collecting information and analyzing information, that only gets us to step 2. That's as far as we've gotten in this part. So that's it for this part of the explanation of problem solving, and there's a second one coming up in just a minute. See you, folks.